Hi everyone. In this video, we're going to continue our work on natural deduction and take another look at some strategies for completing proofs using our rules of implication. So as we work through this video, I kind of encourage you to have the first and second set of rules of implication available so you can refer back to them very quickly. Okay, so when we're doing proofs, recall that what we're trying to do is derive the conclusion um, from the premises where we don't have all of the steps needed to get to the conclusion. So we have here enumerated on the left 4 premises, and then we have over here to our right our conclusion, which is set off with the backslash, right, or the forward slash. So that's always going to be where our conclusion is. Um, so when we're completing the steps for an argument, and we're trying to, in a way, unfold the implicit steps of the argument without by applying the rules of implication, the first step that we want to do is take a look at our conclusion and see if we can't identify it anywhere within the premises, right? So our conclusion is Q, so our goal is going to be Q. That is really what we are trying to extrapolate really from these premises. So I see that our conclusion is appearing in premise 4 as the consequent to this conditional. If not P, then Q. So clearly premise 4 is going to be very important for us. But if we think about what we can do with this premise, it's unclear to me that we can start there, right? If I look back at premise 1, I have not R. Premise 2 says if P, then S. Premise 3 says either R or not S. So I don't think we can actually begin necessarily from premise 4. So I'm kind of getting interested in premise 2, which says if P, then S. We have kind of something very close to our conclusion, but not quite, right? So what are we going to do to try to move this along here, as it were? Remember that natural deduction is really a process of taking complex statements and simplifying them and isolating simple variables. So what I like here is our disjunction in line 3. You will notice that we have in line 3 either R or not S. And because we had in line 1 that not R, we have the ability to, in a sense, rip apart that disjunction and carry over the not S into line 5. So when we do that, we're going to cite lines 1 and lines 3, and our rule is disjunctive syllogism. Remember, disjunctive syllogism takes this form, either P or Q, where in the next line, if we have the negation of one of the conjuncts, not P, we can infer the other disjunct, Q. Okay, so now we have not S isolated in a way that might be more useful for us. Now look over the first 4 premises again and see if there isn't anything we can do with that new S. Whenever we've generated a new line, the chances are you're going to have to use the information or that new premise to previous premises. We can see that that not S is very useful in line 2, right? Because line 2 gives us a conditional if P, then S. And what line 5 allows us to do is to apply modus tollens to lines 2 and 5, right? Remember, modus tollens is this rule where we find the denial of the consequent. So for any conditional, if P, then Q, where we have the negation of Q, we can then infer the negation of the antecedent, not P. And so we are able to apply modus tollens to lines 2 and 5 because that not S is the negation of the consequent. And so now we can bring down the denial or the negation of the antecedent in line 6, thus isolating not P. Okay, so recall that we have used lines 1, we've used lines 2, we've used lines 3 and we have used lines 5. So now have a look over at the remaining line and see if there isn't anything that can't isolate our conclusion for us, Q. You should be able to pick up that the placement of not P in line 6 can be applied to line 4 through modus ponens, right? Modus ponens is our most frequent rule. It's our most sort of commonly used rule, and modus ponens holds that if P, then Q. P, if we affirm the antecedent, we can affirm the consequent, Q. And we do have in line 6 the antecedent, not P, of line 4, not P. So then we can infer the consequent, Q. So once we have Q, we have completed the argument. We have gotten to our conclusion, Q. All right. So this proof required 3 new lines and 3 separate rules: disjunctive syllogism, modus tollens, and modus ponens. All right, let's look at another argument and recall another tactic to go about it. This argument has 4 premises again, and then our conclusion is set off to the right with the / either S or Q. So when working on a proof that includes a conclusion where the final line is a disjunction, the wedge, you might have to use the constructive dilemma. Now remember, constructive dilemma is a pretty convoluted rule of implication. So it's very good to just write it out for yourself. So constructive dilemma, we abbreviate with CD. And the rule is really the conjunction of 2 conditionals, right? Both if P, then Q is the first conjunct. And then as the second conjunct, we have if R, then S. The second line of the rule is the disjunction of the antecedents, either P or R. And if we're set up with that, we can infer the disjunction of the consequence, either Q or S. All right, so that's the standard form for constructive dilemma. Now let's have a look at our argument. It doesn't necessarily mean we can use it right away. We might have to do a little bit of work here to pull it apart. Try to locate the conclusion in the premises, either S or Q. Well, I don't really see either S or Q immediately, but I do see the S and the Q here. Try to pick up on the patterns here that might help us in completing the proof. If S or Q is appearing as the consequence of 2 conditionals, that's a pretty good indicator to us that the constructive dilemma will be necessary, because the conclusion of constructive dilemma is the disjunction of consequence Q or S, right? All right, so I see that in line 4 we have not P, and then if I look back on line 1, I see that we have a disjunction, either P or MR. So see if you can't find a rule that can generate a new line with lines 1 and 4. You should be able to pick up on the usage or the applicability of disjunctive syllogism to line 1 and 4, right? Disjunctive syllogism, again, is that rule that allows us to rip apart the disjunction. So for any disjunction, either P or Q, where we have the negation of one disjunct, not P, we can infer the other because it's an either or sentence. And when we have not P in line 1, we can, in a sense, disassemble this whole wedge and carry over the other disjunct in the new line, either M or R. So we're going to cross off line 1 and 4. Now we have either M or R isolated. And so we have to think about what to do next. You will see that these two conditionals can be conjoined, right? We can bring them together with the rule conjunction. So lines 2 and 3 are kind of the next step in setting up our constructive dilemma. We can bring together if M, then S, and if R, then Q with a dot through the rule conjunction. So now I have this set up. We've used lines 1, we've used line 2, we've used line 3, and we've used line 4. Now see if we can't conclude the argument with our rule. How are we going to use lines 5 and 6 to get to our conclusion, either S or Q? We can apply now constructive dilemma to lines 5 and 6 to generate either S or Q. Remember that with constructive dilemma, we are finding in the second premise the disjunction of the antecedents, M or R, right? So those are in fact appearing in line 5, so that we can infer the disjunction of the consequence, either S or Q. That is equivalent with our rule, constructive dilemma. So just be aware of the fact that the disjunction premise of the antecedents can appear before the conjunction of the conditionals. The order does not matter. The rule of implication still allows us to infer the disjunction of the consequence, either S or Q. All right, so if you have a conclusion with a disjunction, consider using constructive dilemma. All right, let's have a look at the next one. If we have an argument like this, it's very complex. We have kind of clunky lines here. The first line says, if either M or not P, then either Q or not S. The idea here is that if we have complex statements, you might want to consider the rule simplification as a way to go about kind of breaking down the argument into smaller parts. So the first move we can make here is the application of simplification to line 2. Remember, simplification is a great rule that allows us simply to rip apart a conjunction and infer one of the conjuncts in isolation, right? If a conjunct is true, it means, if a conjunction as a whole is true, it means both of the conjuncts has to be true. So we can affirm that M is true taken by itself. Now once we have M taken by itself, it might allow us to do some further things with this argument. We can also assemble, right? We can simplify, but we can also complexify. So in line 4, what I would like to do is to kind of re-engineer or reverse engineer the antecedent of line 1 by adding not P to it. And this will allow us to set up the usage of modus ponens in line 5, right? Because now that we have the antecedent of line 1 affirmed, we can infer the consequent in parentheses, either Q or not S. So once we've done that, we have our conclusion and we've gotten there. So think of, again, natural deduction as a process of assembly and disassembly. In this case, we disassembled our conjunction with the rule simplification, only then to add to that simple variable not P to establish the antecedent in the next line in a manner that was able to get us to infer the consequent, either Q or not S. All right. Okay. Here's another tip. Recall the strategy for conjunctions. When working with a proof that has a conjunction in the conclusion, first identify and derive the conjuncts, then apply conjunction. Remember, conjunction is a rule that allows us to bring together isolated variables with the dot. So we do have in this argument a conjunction, both R and S is our conjunction. Let me get out of the way here a little bit. So the first thing we want to do, again, is try to look for the conclusion in the premises. I don't see R and S as a statement in the premises, but I do see R as the consequent in line 2, and I see S as the consequent in line 3. So this indicates to me that at some point we're going to have to break apart our conditionals, right, to get them isolated in order to then conjoin them again. So what are we going to do? In line 1, I think we can kind of begin working by simplifying the conjunction. So generate in line 4 P through the rule of simplification. We can isolate P by ripping apart the dot in line 1 through the rule of simp, right? Simp allows us to isolate single variables in any conditional. Once we have P, we can then also infer Q through simplification. So now we have some much more simplified expressions that allow us to then use what we've created in lines 4 and 5 by applying them to lines 2 and 3. So you can probably see by now that modus ponens will be a way that we can further simplify the conditionals, right? If we apply modus ponens to lines 2 and lines 4, because we now have the affirmed antecedent P in line 4, we can infer the consequent R in line 6, all right? All right, so we've used line 1 twice, we've used line 2, and we've used line 4. So how do we generate the next line? Well, we see in line 5 we still have our Q that's isolated, and in line 3 we do have if Q then S, so we can use modus ponens again to isolate S, right? Modus ponens allows us to infer S because we have the affirmation of the antecedent Q. So we've now used 1, 2, 3, 4, and 5. And in line 6 and 7, we now have R and S in isolation. And we see that our conclusion again is both R and S. So the rule that allows us to bring them together, of course, is conjunction, the dot. In line 8, we can bring R and S together with the rule conjunction. So we're going to cite lines 6 and 7. And once we are there, we have derived our conclusion, right? So with conjunction, conclusions that are conjunction, you might have to apply simplification to the premises. Okay, that is enough for now. In the next video, we are going to do some practice on natural deduction, which is really the only way to become familiar and to have the ability to use the rules of implication for completing a complete proof. So be prepared to follow along with me and derive new lines using these rules of implication.